So we're going to be looking on water, plugging back my laptop. So when we look on water, water is we need to talk about the unique properties of water and how each of those are important to living organism. So water is a polar solvent, so that is the property of water. So for each of them, the property of water is in bold, and the explanation and their importance to living things are not bolded. So water is a polar substance. So water can dissolve a wide range of substances. So it dissolves substances essential for metabolic processes in living things. So for example, respiration, digestion, and any other thing we need in the body, we need water. It also, so for plants, it also dissolves nutrients in the soil so plants can get them to grow. Water have a very high specific heat capacity. Heat capacity mean in order for you to change the temperature of water by 1 degree Celsius, we need 4,200 to change 1 kilometer, 1 kilogram of water, sorry. So in an ocean or a lake that has very, very large volume of water, large mass of water, to change the entire ocean by mass, whatever the mass of the water is, you to multiply that by 4,200. So because water have very high specific heat capacity, it keeps living organism. It helps living organism to maintain a constant body temperature in ambient temperature. So this ambient means low or high. So even in the winter, when we have organism, it's very cold. In order for us to get cold, our bodies are not going to get cold like that internally, because we have a lot of water. So we need to lose a lot of heat in order to change our body temperature, right? You think about the ocean, the temperature of the ocean is pretty much constant in wintertime and in summer, because it's not going to heat up very fast because of the amount of heat energy it needs to change the temperature of water. So the high specific heat capacity of water helps living things to maintain constant body temperature, right? When ambient temperature rises. So that's why. Water also have a high heat of vaporization. Vaporization is our ability for water to be converted from liquid water to gas. And it takes about over 20,000 joules of energy to change 1 kilogram of water to gas, right? So the reason why this is important is when it gets hot, humans are going to sweat, right? When plants get very hot, they are going to transpire and they will produce water. Now, because to vaporize this water, so one of the things is when you are hot, you are not supposed to wipe off the sweat because it defeats our body from cooling down. When the sweat is on the surface of the body will have to produce a large amount of energy to get rid of this sweat. So when it produces this heat energy, after the sweat evaporates, we cool down. The same thing for plants. So the evaporation and transpiration cause cooling of living things, as a large amount of energy is needed to remove sweat from plants and animals, thus cooling them down. So when the sweat evaporates, it removes a large amount of heat energy, so plants and animals will stay cool. All right, that's what's up. No water, ice have a different density than water. The density of ice is less than liquid water. So when water gets around to 4 degrees Celsius, it expands, so it becomes less dense. So water density decreases on freezing, so ice is on top of liquid water. So for aquatic organism, the liquid water beneath ice will stay warm to support aquatic plants and animals. So that is why organisms that live in lakes and ocean can thrive in the wintertime because the frozen ice stays on top and they're insulated by the warm water down the bottom, so they can continue to respire, grow, and reproduce in the wintertime. Now, the solvent property of water is extremely dangerous because water can dissolve is in the body, and we can also have leaching. So, never tell John Mark about leaching this morning. Let me write leaching here. All right, so leaching of the water is washing away of is the washing away of minerals and nutrients from the soil. So as water moves over, what it's doing is dissolving chemicals that it passed over, and it's carrying it along with it. So it is the washing away of minerals and nutrients from the soil. Of mineral and nutrients from the soil. All right, so that's leaching. So also water being polar can dissolve some dangerous chemicals. So for example, it dissolves oxides of nitrogen, oxides of sulfur. And when it dissolves that, what's happening is that we have acid rain, right? So water, because of this property of water being a solvent, it can form hard water, and we have two types of hard water. We have permanent hard water and temporary hard water. So hard water contains dissolved ions of magnesium and calcium. So it depends on the anion that we have that's going to tell us if we have permanent hard water or temporary hard water. In some books you may see hard water does not lather soap. I'm not focusing on that definition here. I'm focusing on exactly what it is. So you wouldn't be wrong, but for the purpose of this class, this is what I'm focusing on. So hard water contains dissolved ions of magnesium and calcium. So we have two types of hard water. We have temporary hard water, meaning that it is only for a time, right? And we have permanent hard water, meaning that it will stay there for a long time, more like on the permanent side. So temporary hard water still contain magnesium and calcium ion, but the anion that is present is the hydrogen carbonate. So water that has dissolved magnesium and calcium hydrogen carbonate, that's going to be temporary hard water. So we need to be able to talk about how temporary hard water is formed. Now, carbon dioxide is a gas in the air. So carbon dioxide in the air dissolves in rainwater and it forms carbonic acid. Carbonic acid now passes over rocks containing magnesium and calcium carbonate, and it will form calcium and magnesium hydrogen carbonate, right? Now, all of this can occur in one step. I'm going to show you how it happens step by step, but everything can happen in one step. So the first thing I'm showing you is that water and carbon dioxide forms carbonic acid. This is not the arrow I should have here for carbonic acid. Carbonic acid is a weak acid. So this is the arrow I should have here for carbonic acid. So carbonic acid is a very weak acid. So carbonic acid now that is formed where we have slightly acidic rainwater. So it's not as strong as our rainwater or acid rain from sulfides of nitrogen or sulfides of nitrogen or sulfide. So it's a weaker acid rain than those. So what's happening is that the carbonic acid that's formed in the water will react with calcium carbonate or magnesium carbonate to form calcium hydrogen carbonate or magnesium hydrogen carbonate. As I said, this is it step by step, or everything can occur in one step. where you have carbon dioxide, water in the rain combined with carbon dioxide from the atmosphere reacts with rocks containing calcium carbonate or magnesium carbonate, and it forms calcium hydrogen carbonate. So we have one entire reaction occurring here. Good job. So, I mean, wherever we have calcium, we can also have magnesium, right? So again, this is one reaction, and this is fine if you give only this reaction. This is what you can give. And again, in case they're asking you for magnesium, form temporary hard water using magnesium, this is what we would have. We would have water, and this water comes from rain. Carbon dioxide gas reacts with a magnesium carbonate. And when it does react with magnesium carbonate from rocks, so these are in rocks, you will have magnesium, I meant to say calcium. You're going to have magnesium hydrogen carbonate forming. All right, so based on what I was reading this morning from CSEC report, there's a student tend to not write this formula correctly. So the formula is Mg open bracket H CO3 close bracket 2. That's the formula. So once we have these ions in the water, and remember hydrogen carbonates are more soluble. So hydrogen carbonates are soluble compared to the carbonates. Carbonates are insoluble. So all hydrogen carbonates are soluble. Most carbonates are insoluble except sodium, ammonium, and potassium. So these are soluble in water. So once we have these ions in water, we have temporary hard water. So we have also permanent hard water. Permanent hard water is when we have magnesium sulfate or calcium sulfate. What's wrong with me? Am I writing? So permanent hard water is when we have calcium sulfate or magnesium sulfate dissolved in water. So the ion which causes temporary hardness, let's just use temp, is the hydrogen carbonate. That's the anion. So remember, and the one which causes permanent is the sulfate, right? So remember, all hard water have dissolved calcium and magnesium ions, right? If you have calcium and magnesium hydrogen carbonate, then we have temporary hard water. If we have calcium or magnesium sulfate, then we have permanent hard water. So formation of hard water. So rainwater run underground, dissolved in rocks containing magnesium sulfate and calcium sulfate. So we have gypsum rocks which have calcium sulfate. And when they dissolve them, they form permanent hard water. So here we have an equation for it. We have rocks containing magnesium sulfate. They dissolve, so when they ionize in water, they are going to form magnesium ions and sulfate ions. Calcium sulfate rocks, once the rain fall over them, it's going to dissolve them, carrying them in the water, so the water becomes hard. So we have calcium Ca2 plus ion and SO4 2 plus 2 minus ion. So this is them dissolving rocks already. In some cases, we have another way that hard water can form. So it says magnesium and calcium ions are dissolved out of rocks. So it's just the ions that dissolve, right? And become soluble. The aqueous magnesium and calcium ion can then combine with sulfate, producing magnesium or calcium sulfate in solution, which leads to the formation of hard water. So the dissolved magnesium ions combine with the dissolved sulfate ions in the water, and they form magnesium sulfate, right? Now, or the dissolved calcium ions in the water from rocks, combine with sulfate ions from the water to form calcium sulfate aqueous. So the first one that I gave you was water finds rocks that already have magnesium sulfate in them and they dissolve them out, or calcium sulfate. And in the second scenario, we have the water carrying some calcium ions with it. It finds some sulfate ions, right? And when it combines, it forms calcium sulfate or magnesium sulfate. Right, to remove temporary hard water. So remember, temporary hard water is formed when we have magnesium hydrogen carbonate in water. So we have calcium hydrogen carbonate in the water. When we boil it, we're going to have decomposition occurring where we have heat, and it's going to form all the raw material. So remember, last time we were forming the temporary hard water, we reacted carbon dioxide, water, and calcium carbonate or magnesium carbonate to form it. So what's happening is so when we heat it, when you heat water containing magnesium hydrogen carbonate, what's happening is we are going to reform water, carbon dioxide, and the carbonate. So we're going to form calcium carbonate, water, and carbon dioxide. And if it was magnesium hydrogen carbonate, this is 2. Nobody now correct me. What is wrong with me and this too? All right, so what is happening is that, remember, in order for the water to be hard, it must contain the dissolved salt. Now, when we boil it, what is forming is calcium carbonate and magnesium carbonate. So these are solid, so they are no longer in the solution. And we call this in our pots lime scale. So when you boil your water in your kettle and you see some deposit of white substance, it is the calcium carbonate that is that's coming out of the hard water that's going to give you this lime scale buildup. Now, in order to treat the lime scale buildup, we can just add some acid, for example, your vinegar or your lime juice in your kettle or your pot. And when you add the acid, what ions can we form? So if we want to treat the lime scale and we add acid to the lime scale, what's going to happen? When carbonates react with acid, we form a salt. So we're going to form calcium salt, hydrogen, water, later. Paris, Dove, or I can buy the one in the bathroom. Or St. Ives. Ready? So we need to balance this. So we have Ca, 1 carbon, 1 carbon, 3 oxygen, 1 oxygen, 2 oxygen, 3. 1 H, 2 H. How do we balance the H plus ions from the acid? We'll put a 2 there. Clear?
Yes, yes.
4 day.
4 days starting to. Yeah, because she do. Yeah, that's all.
All right, any question? All right, so another way that we can treat, this treats both permanent and temporary. So I'm gonna focus on take my phone and make the call. John Mark, why you never tell me say this never balance this morning? You beat you up, you know. So we are going to balance this equation. So this treats both permanent and temporary hard water. So sodium carbonate, which is baking soda, is added to the water. So remember, all sodium salts are soluble. So once you add it to the water, it's going to become aqueous. So baking soda adds to water, it's going to react with the magnesium or the calcium hydrogen carbonate. Put the 2 this time. And what's happening is we are going to have a double displacement reaction where the anions are switching. So the sodium will now marry the hydrogen carbonate and we are going to form, and the magnesium will marry the carbonate. So what we have is this, the magnesium ions will no longer be in solution because they are precipitating out of the solution. So to balance this equation, we're going to put 2 in front of this sodium hydrogen carbonate, and that's how we balance it. Now it will be the same reaction if we use sodium carbonate and calcium hydrogen carbonate. We're going to form 2 sodium hydrogen carbonate. So the ions now in the solution is the sodium ions, which does not cause hard water. And we're going to precipitate out the calcium ions. So this is coming out. We just strain the water and that's it. So this is to treat temporary hard water. That's what we're on. Now, permanent hard water can also be treated using our sodium carbonate. So sodium carbonate would have in it, would react with the magnesium sulfate. And when it reacts with the magnesium sulfate in the water, we have a double displacement reaction occurring. So we're exchanging anions. So we're going to form sodium sulfate and magnesium carbonate. What fear cloth there? Why fear cloth not the other class here? 2 Na, 2 Na, 1 carbonate, 1 carbonate, 1 magnesium, 1 magnesium, 1 sulfate, 1 sulfate. So the same thing would happen. With fear cloth, the fear cloth went up. And read. Why
No, miss.
Miss Reed is present.
Read is what?
Present, Miss.
Okay. Walters is here. And Monkry and them girly. Monella is here and Kayla.
Miss, I'm here.
Hello, you know. Kayla and Kimura, I'm if you ask for calcium carbonate. So calcium carbonate is the solid, so it's going to precipitate out of the water, so the water is no longer hard. All right. So the next type of way to treat hard water is ion exchange resin. So we have a resin which contains sodium, right? So sodium ions are on the resin when water passes over the resin, when hard water passes over the resin, the sodium ions are replaced by magnesium or calcium. She don't need none of that. She needs the garbage. So here we have, we have 2 sodium ions on the resin. R is just the resin. I don't care what R is, right? And then I'm going to add calcium ions to it. So what's happening is a single displacement reaction, right? Where the sodium ions are going to come out and join the water. So we're going to have 2 sodium ions forming, and then the calcium ion will combine with the resin. Clear? R is resin. Whatever anion is on the resin. I'm not interested. Your syllabus will tell you zeolite or something like that. I'm not interested in what R is. What I need to know is that the calcium ions are no longer in the water. They're going to be on the resin, so the water is no longer hard. Or if it was magnesium ions in the water, the magnesium ions would be replaced to replace the sodium on the resin. So we have magnesium on the resin, and we have 2 Na plus ion forming. So the resin is some semi-solid thing. The calcium ions are in the water. Of course, they're aqueous. So the sodium ions will now go into the water where they're aqueous, and will form the magnesium, and the calcium takes the place of sodium on the resin. So they are no longer on the water. Right? All right. So we're going to answer some questions. Okay. List 4 unique properties of water as it relates to the human body. Give me one. High what?
Miss high heat of vaporization.
So although the question I never ask it, the question we actually ask if you explain the property, me delete them. I never put them on this question. So if it asks you to explain it, what would be your explanation, Joel? What would be your explanation? I'll put explanation in red. That's on a red. Anybody?
Miss, so basically it is used to remove the sweat from animals and plants from the cooling. Yes.
So large amount of heat is removed from plants and animal when sweat evaporates. So it cools them down. So that's the property. So this is the explanation not needed for this question, but I don't know why I thought it was needed for this question, because another question I deleted from the handout. So let's go. John Mark, give me one.
Miss Water is polar, allowing it to dissolve many compounds.
All right, so the property only for this question is water is polar. No, water is a good solvent. So that's the property. Water is a good solvent. That's the property, and the explanation is So it dissolves a wide range of substance. How is that important to the human body?
It's a transport nutrients.
In a human, so it's needed to dissolve substances for what kind of reaction? Metabolic. Why I don't think the word is spelled right in a metabolic reaction? Example, digestion.
Miss, you have metabolic. It's metabolic.
Me know I not spell it right. Also spell it. I don't know how to spell it. No L no for there. That's it. Me no know me
Yes,
can't
it's
spell.
no L.
All right, next. So listen, since your mic is open, let's go give me a property. So remember, red is not needed. I'm just recapping, right? Let's go.
Miss, it regulates body temperature.
So a unique property of water.
Oh yes, specific heat and
So it have high, this in a blue. So high specific heat capacity. So it regulates how that go?
Miss Tier says she'd like to answer.
Oh, yeah, explain this. Are you doing a fourth one? Then Johnny, no, listen, I explain this. It's regulates body temperature as what? It requires a large amount of energy to heat up. So body temperature remains constant. So because it needs a large amount of energy to heat up, it's not going to heat up. So body temperature is gonna remain constant. So this one will listen. So that's how I converted my explanation. Somebody else give me one. Who says they're gonna answer the next one? They can answer it. Go ahead. Human body. The density. I got affect it.
It's dense.
It's not gonna affect the human body. Density gonna affect the human body? No, as it relates to human body. I don't know what the next one.
Miss her melting and boiling point.
Hi, what?
Melting and boiling point.
All right. Okay. And all right, it's gonna be similar to the other one. So explain it. Come, Bailey.
Miss, so as it pertains to the human body, miss, because it has a high melting and boiling point, and the body is 60 to 70% liquid. The the water doesn't like boil out of our body.
All right, water exists solid, liquid, and gaseous state. Describe a test for water vapor. How we testing for water vapor?
If you place a piece of dry cobalt in chloride paper in the gas, blue to pink.
It's anhydrous. So we're going to add anhydrous cobalt chloride paper. And if water vapor is present, what would we observe?
The paper goes from blue to pink.
Check the color. And I other way around, me no know.
Oh, miss, it's blue to pink.
And I just blue chloride paper. If H2O gas is present, blue to pink. And then, or what else? And I just what?
Okay, so pink.
Sulfate.
Color change.
White to blue.
Some Caribbean islands, calcium hydrogen carbonate forms temporary hardness in water. This can be treated using washing soda or sodium carbonate. There's a balanced chemical equation, including state symbol to show the removal of temporary hardness from water using this treatment. So we're gonna when I add washing soda, what's the formula for washing soda?
Na2CO3.
What's gonna happen? What's gonna form when they exchange ion? Gonna form calcium carbonate and sodium hydrogen carbonate. Balance it by putting a 2 there. The presence of certain ions in water causes temporary and permanent hardness. Hard water is a serious concern in the laundry industry. Rice is a serious concern because it wastes one whole heap of soap. That's why it's a serious concern. What is meant by the term hard water? So what is hard water?
Water that contains ions of magnesium and calcium.
Write the formula for each of the following. A compound which causes temporary hardness. What causes temporary hardness? Why nobody can answer on 24? I wanna
Calcium hydrocarbon.
or what?
Magnesium hydrogen carbonate.
The ion which causes permanent hardness.
Calcium sulfate.
The ion.
Sulfate.
Sulfate.
So it's the anion they would want, which would be the sulfate in this case. Sodium carbonate is widely used to remove both temporary and permanent hardness, while temporary hardness may also be removed by boiling. Write an equation to illustrate the removal of each of the following permanent hardness using sodium carbonate. Who is answering that? Somebody who I have not heard from morning. I will do it already, so let's go. Permanent hardness would be magnesium sulfate, and what would be the equation? What's the product forming class?
Sodium sulfate and magnesium carbonate.
All right, or you can use calcium as well. Doesn't matter. Temporary hardness by boiling. Who is doing this one?
Miss, calcium hydrogen carbonate, when you boil it, it produces calcium carbonate, water, and carbon dioxide.
Just give me balance. Give me formula them. C open bracket.
Ca open bracket HCO3 close bracket 2 aqueous produces CaCO3 solid plus H2O liquid plus CO2 gas.
All right. Compare the effect of soap and soapless detergent on hard water.
Miss, soapy detergents do not pollute water because they are biodegradable and they do not contain phosphate, while soapless detergents can pollute water because some are non-biodegradable and they contain phosphate.
Right, well, that is true. I'm not looking for that right here, so that's fine. That's correct, but I'm not putting that there right here. The soap will form what?
Scum.
Will form scum when added. So hard water. And what's gonna happen to the other one? Soapless detergents will what?
Sodium.
Will not or will lather to
Easy.
form sod. It's a sod in hard water. Clear?
Yes, miss.
We're done. I find my exam, see if you can answer a water question upon my exam. Let's just see how bright you are. Studied my exam in 2006. I'm a young girl before I did ban. Let's go. Let's see if y'all can do it. It was my question 5 or 6. Let's go. Oh, I used to not do a while ago. So I reach here, so. So we explain it already. So let's just talk about it. Water possesses a number of unique physical properties, which makes it an ideal transport medium as well as a medium for various chemical processes occurring in organism. These are the unique properties of water. So solvent properties, specific heat capacity, volatility. Volatility is the same as the specific heat capacity. Specific latent heat of water is high. Discuss any two of the above property of water as it relates to processes occurring in living systems. So we do it already. So just run through it. Persons just pick a property and run through real quick. Let's hear what you have to say to see if it's correct or incorrect. Who's going? Joe McCammon Jr. Ray, let's go.
Water,
Okay. Joe, go ahead, Justin, and then Ray.
water has a very high specific heat capacity, and it helps living things to maintain a constant body temperature.
In ambient condition or temperature. in ambient temperature. All right. Anybody else answering? Ray, where the Ray?
Water has a latent heat of vaporization, and this helps to regulate body temperature through sweating.
Me not say regulate, me I go say cool. So it helps to cool down. The body as a large amount of heat is removed when sweat evaporates. So it have a high volatility. So when sweat is removed from the skin, a large amount of heat is removed from the body, keeping the body cool. Anybody else who want to talk about the solvent property? Solvent property. Solvent property. Monique, me not hear from morning. Let's go. Tovia, let's go. Come Tovia, unmute the mic and answer me a question, please and thank you. All right, Steer, go on. Come choose Steer.
Miss, it dissolves substances for metabolic processes of living things and also nutrients in soil.
Okay. All right, so that's it for water, all the best. If that comes on the exam, you should be able to do that.